So last class we were discussing about data types, and data types in Java we saw. Java's data types are very rich as compared to other language data types. Java's data types are very rich. I was talking about typecasting last class. I'll just cover some more. I have to use some more points on typecasting. For implicit, I've given all the points. Just check all the points. What I've given for implicit casting? Typecasting. Typecasting is a process of converting one type of data to another type, or it's a process of converting one type of value to another type of value. There are two types of typecasting now. Yes. Implicit and explicit casting. Implicit casting, what I gave notes? It is a process of converting smaller type to bigger type, or smaller value to bigger value. It happens implicitly. It is done by the JVM itself, and there is no loss of data. There is no loss of data. These points are there now? Okay. So implicit casting means, I told you about this also yesterday. See this class demo PSVM. You can write public static void main. See, int A is equal to 0, byte B is equal to 5. Now I want to give the value of byte to A. So what happens now? First, A memory will be allocated. I'll be showing you with coding also today, don't worry. So the value of A is what? Initially 0, sorry, it will be 32 bits. So I can't write all 32 bits, just understand only the last 8 bits I'm highlighting and writing. It will have 24 bits, all will be 0, and this will be A now. Next we are having B. What is the value of B? So this is B. So if you want to give the value of B to A, it's very easy. Okay. This is called as widening conversion. Widening means what? The value gets widened and gets stored into this one. So this is widening conversion, or this is also known as implicit casting. Implicit casting means you don't have to, developer does not have to do anything. It will be taken care by runtime. Developer doesn't have to do anything. So this is an implicit casting. Okay, the same if you do ulta, we'll see int A is equal to 5 now, byte B. This is another program. Think that this is another program. This is program number 1, or this is program number 2. Another program or scenario you can take. But don't declare it again in the same program, because A has already been declared as what? Int. Again, don't try to declare once again. It will give you error. So think this is as another program. Int A is equal to 5, byte B is equal to 0. So B, the same thing now, ulta, what happens? See, in the previous case, this value was getting stored here. Value of B was getting stored here in the previous case. So it will store. So 8-bit can be stored in 32-bit now. 8-bit can be easily stored in the previous case. Means implicit casting this will happen. But now the scenario is different. What are we supposed to do now? We are supposed to give bigger value to smaller data type. Now it's not possible, because now see, the case is this, ulta it is. Now the case is ulta. Like you want to store 32-bit into what? 8-bit. This is the second case now. 32-bit cannot be put into 8-bit. So this is the problem. So that's why what you have to do, so the compiler will warn you, because it's Java is strictly type checked. It checks what type of a value you are giving to the variable. Okay. So it will check the type and all that, it will check and it gives you the error. This is advantage, because in Java, in C what happens, or in other languages, junk values will getting stored, or some value will be stored, which you can't predict only, and they will be used also in runtime. But Java avoids such kind of problems. So this will not happen. So what the developer has to do, he has to explicitly do it. He has to explicitly do it. So that's some points we'll give for explicit casting. Now write it down. We wrote some points yesterday, but some more points to add. Explicit casting is a process of converting what? There only you can write. You wrote yesterday some points. Now if you have space, there only write. 1-2 points I'll give. That's it. Explicit casting is a process of what? Converting bigger data type to smaller data type. But precisely it is converting bigger value to smaller value, to be very precise. And this is called as narrowing conversion. You're narrowing the value. Earlier the value was getting widened, but now the value is getting narrowed down. So that's why it's called as narrowing conversion. Write one point there. it has to be done explicitly by the developer. It has to be done explicitly by the developer. Explicitly by the developer. It has to be done explicitly by the developer. Narrowing conversion has to be done explicitly by the developer. Explicitly, developer has to do it. See, this is explicit casting. Are you getting it now? And this is error. Why it is error? You are trying to use some value to some data type, it will give you error. So this will give you compilation error. Compiler wants you are trying to use some value to some variable, be careful. But still if you want to give, you have to do it explicitly. So this is understand the difference. This is a syntax. This is a syntax for implicit casting. This is a syntax for explicit casting. Understand? This is a syntax. So whenever you see the code like this, understand that you are doing explicit casting. So that point you wrote down, it is what is the point you wrote? How many points are there for explicit casting? It is used for converting bigger data type to smaller data type. It is used for converting bigger value to smaller data value. Then one more point what you wrote is what? It has to be done explicitly by the developer. And when we are doing explicit casting, if the value is outside the range, there will be loss of data. That's one point you have to write. If the value means when we are doing explicit casting, if the value is outside the range, there is loss of data. In explicit casting, there might be loss of data only when the value is outside the range. There might be. I'm not saying it will. If it is within the range, there will be no loss of data. So here loss of data will not be there. It is within the range now 5. Loss of data will not be there. 135, loss of data is there. 5, no loss of data. But the same if I say A is equal to 135, loss of data is there. So when an explicit conversion is getting done, or explicit casting is getting done, okay, developer has to do it explicitly. But when the value is outside the range, there is possible loss of data. So loss of data happens only in explicit casting. It does not happen in implicit casting. So all this I will type and show it to you today. Whatever we saw yesterday, all this I will type and show it to you. Just 2-3 points I had to give you, so I just gave you those points. Okay, so what is that? One is, see, this is the syntax. I didn't write it, that's all. I wrote it, but I just didn't highlight it by writing like this. So that's one thing. And implicit casting, no loss of data. Here no loss of, because smaller value are going to bigger one, there is definitely not going to be any loss of data. So some points. Are you clear with all this now? Only in explicit casting there will be loss of data. Possibly, not always. Then one more point I was covering yesterday. You understood now? Covering now. This will be put into what? Now A value will be put into what? B. 101. 32 bit will be. This is narrowing conversion. You understood what is widening and narrowing? So widening will be done by runtime itself. In all languages, this is a common thing. In all languages, this is common. Only Java is more powerful here. Okay. Means it's very precise. Java is very precise in doing all that. You will understand all this precision. Then one more. Yesterday I told it is correct, but only one thing what I did was double value. Double value can be represented in what way? Standard notation or your floating value. Floating value can be stored in what? Standard notation, scientific notation or exponential notation. I told correctly only, but one second, I'll just scientific notation or exponential notation. Standard notation, I told it correct, no issues about that. See, example, double D. If it is double precision value, just write double D is equal to 129.59 over. Correct. This is how you will go with standard notation. This is an example for what now? Standard notation. Similarly, you can write double so double D is equal to 75,000 also you can write. Dot I am putting. Okay. So then what you can do, these are all standard notation. Sometimes if you want you can go for scientific notation also. We go with scientific notation when the values are too small or too big. Only in these conditions we go for what? Scientific notation. Too small or too big. But very rarely we use scientific notations. Don't bother about that. Very rarely we use scientific notations. Don't bother about that. Just I'll show you now. The same 75,000 if you want to store here, what will you do? Double D is equal to 7.5 E. I wrote 10 to the power of 4. Actually, you should not write. That's not the syntax. That's how it is getting evaluated. I actually wrote off how it is getting evaluated. But you have to write it like this. E4. This is the syntax. I should not write 10. You should not write 10 to the power of 4. You should write only E4. It gets evaluated in this way. How it will get evaluated? 7.5 E4 will get evaluated internally as. When I was writing, I went on to explain how it is getting evaluated. It will get evaluated like this. And obviously it becomes what? 75,000. Or also you can write what? 75, this is correct. Okay, this is scientific way. Or you can write 75, 7.5, capital also you can use. Or you can write 75, 7.5. This is 7.5 E4, 7.5 E4. Or I can write 75 E3, 75 E3, all are valid. But the same if I want to represent, see another value I'll give you, 0.00075. So this is standard notation. If you want to go with scientific, how will you do? D is equal to 0.75, or you can write 7.5 also. Many ways are there here. 7.5 E what? Minus 4. That's it. Or you can write 7.5 E minus 4. Caps also you can write. Done? Or you can write 75 E what? Minus 5. 75, not 7.5. 75 E minus. This also you can write. So you should know how to write this. Finally it will get evaluated like that. See, 7.5 E minus 4 will get evaluated as what? E minus 5 will get evaluated as what? 7.5 into 10 to the power of minus 5 internally. So this I'll code and show you today. You'll get the clarity. So you can store your values either in what format? Standard notation or scientific notation. Your floating values can be stored in two ways. Standard, scientific. Standard only we use. Maximum we use what? Standard only. We don't use scientific. Maximum. Okay. Well, we use scientific notations only when you want to store very small value or very big value. Very small value means what? 0.00000, something like that. Or very big value means what? It's very big. So you can write 75 into 10 to the power of 29. Finished. Instead of writing 29 zeros, 75 E to the power of E29 you can write. And the syntax goes like this. What is the syntax here? Everything I wrote correct, but only I evaluated and wrote it. Mantissa E exponent. Syntax is correct. See, mantissa is this 7.5. E exponent is what? 4 or whatever it is. Don't write 10 to the power of 4. That's the wrong syntax. It gets evaluated like that, but you have to write it like this. This is one small correction what you have to do. Clear? Okay. So I'll type these programs and show you all this, what we learned yesterday today. Okay, and we'll get finish off data types. But still it's a big subject. Data types is a big subject. We'll continue with that also. Clear? Shall I clear what I have written everything now? Whatever I have written I clear now. So I'll start seeing one by one all the programs now. Mantissa E component. Here also what is this? This is mantissa. This is E. This is exponent. Clear? Yesterday while writing exponent we made a mistake. 10 to the power of 4. Actually you should write like this. I went on to write like this, but instead I went on to evaluate it. That's all. So I'll continue to type the programs now, data types. So for coding what you'll use now? You can start using Edit Plus, it's very simple. Okay, you can start using 8 plus, it's very simple, and it will highlight the programs also, you know the advantages. So you put the shortcut on Edit Plus on desktop, it will be easy to open. Double click, it will open, and you can start typing. File, new, Java, fine, you'll get it. So you can write. First we will go with byte itself, if you want. Byte demo. So you have to save the file. So where will you save now? You can go for one more folder today. 04, what you will type? Data types. Save a program. Byte demo.java. Or one second. Instead of this, I'll give data type demo. Data type demo. Data type demo.java. Any name you give, that's your wish. First check whether the program is working or not. Control 1 compiles, Control 2 executes. So this is the way you are typing your program now. So if you want, you can write now. Byte b is equal to 5. Byte b is equal to 5. And now say byte b is equal to 5. If you want, you can print the value. System dot out dot print ln. You can print. What is the value print? Value of b is plus b. Correct now? So first let us look at this statement now. You are trying to give a value. What type of a value it is? Numerical value. It is a numerical value. So I have to, and it is a whole number value. It's not which one? Fractional value. So to store this, first you start seeing a value always. Left hand side can be any data type, but it should be a corresponding data type. So I have to use the data type which will hold numeric values which supports whole number. So which are the ones? Byte, short, int, long. I can use any of the 4, but I decided to use byte. Let us see how to work now. So like this you have to decide. You will get values now. When you get values, you should understand which value to store where. Clear? So anyway, we are hard coding right now. These values will come dynamically. So when I get dynamically the values now, you should know exactly where to store that value now. Here I am hard coding now. Dynamically means what? From the interface you get, from the UI. User will give the user interface, man. UI means user interface. So the user will be giving the value from the interfaces and it will come to your application. So let's see now. So Java is giving a very powerful support to hold what? Whole number values. See what support it gives. Perfectly it works. But internally what did the compiler check? Why did the compiler compile? The type of value, the range of value, the size of value, all are correct. So it will store it into this byte. Understood? It will work. So next, if you want, see this. 125. It is within the range now, still within the range. Compile, execute. But what happens if it goes outside the range? 129. Now it will not store. It gives the error. Compiler warns you. See, it will not store junk value unlike C. In C what happens? You try to store a value outside the range. Some value, whatever it understands, it will store. So it will compile. You will be very happy. Oh, your program got compiled. Because as a developer, your first thing is what? First, whether you write the program or not, whether it's empty file or not, your first thing is what? The file should compile for you. Okay. But anyway, see, if the file gets compiled, where's the problem you're getting now? You get it during runtime. But here, Java prevents that. So how good your compiler is, that beneficial it is to the developer. So how much are mistakes you find during development, it is always good. Reason is, you will not face problems during runtime. Remember this. Clear? So it gives you this error. So what should I do now? So what is the problem now? Range is the problem. So I have to bring it within the range. How will I bring it within the range now? Typecast. You know the syntax now? But how will the typecasting work now? See, this is the range. Minus 128 to plus 127. So this is 0. So from the positive, if it is outside, it swings towards the negative and it will count 2 numbers now. See, byte B can store 256. The exact capacity of this is 8 bits. A byte can store 8 bits. if you enable all the 8 bits, it will become 2 to the power of 8. Means it can store 256 numbers. Range is from minus 128 to plus 128. So if I try to store, what will happen now? It is not going. So now 129 cannot be stored here. It's outside the range. So it will swing now. And start counting. 127 numbers over this side. 128, 129. So it will become minus 127. As simple as this. Clear? So still more you can take. You can go up to what? 135. Any value you want to give. And the same 153, 135. So that time what will happen now? Or 130 I will take, which is very easy for us to understand, to learn. So that time what happens? It compiles. Then see, from 127 numbers over. So now how much it has to move now? 128, 129, 130. It becomes what? Minus 126. Fine. It means, so there is loss of data. When you are doing explicit casting, there is always loss of data. Not always, sorry. There is sometimes loss of data when it is outside the range. So this is actually what? Explicit casting only for you. Done? This is explicit casting only. So now if I go up to 255, what is the value of 255? Can you guess? Minus 1, I think. Minus 1. 256 will become what? 0. Perfect. Now 257 will become what? 1. Now from positive to negative, negative to positive. Very simple. But modulus ratio will be applied. It will not go on cycling like this. If it exceeds 256, immediately it will apply the modulus ratio. What is the remainder? 1. Now 1 it will start counting. 1 number, 2 number, 3 number, it will start counting like this. So 1 it will start counting like that. Okay. Then again, you see, I will take it up on more higher levels. 256 plus 128 I will do. 14. 5 plus 2 is 7, 8, 384. So what will be this value now? 384. What will happen now? Minus 128. From positive again it goes to negative. So if I go with still 439, again what happens? Negative side, it's minus 73. Like this it goes on. So by the time I make it 512, it will become again what? 0. So like this it goes on, positive, negative, it will go on. But here modulus ratio will be applied. 2 times it will divide, the result is 0. It will not go on swinging. Once the modulo remainder is got, then it will take that value and do positive and negative swinging. Any questions here? Same will be done for what? Short also. You know the range short? So range of short? What is the range of short? You know the ranges, no? Now see this. We'll see the byte. Short. The table you see now. Data type. Size. Default value. Yes? And range. I think I'll write it that side because here we need this space. And data type, size, range or default value, last thing is range. This is for whole numbers what I am telling. So byte, short, int, long, 1 byte, 2 bytes, 4 bytes, 8 bytes. Default value is what? 0, 0, 0, 0. I wrote the range in 2 ways. You can take it like this: 2 to the power of 8 minus 1, minus 2 to the power of 8 minus 1, to 2 to the power of 8 minus 1 minus 1. 2 to the power of 8 minus 1 minus 1. You can take. Or it can also be written as byte value is what? Minus 128 to, you evaluate it, same result you will get. Same way, short will become what? Minus 32,768 to 32,000 767. But we can write it like this: minus 2 to the power of 16 minus 1 to 2 to the power of 16 minus 1 minus 1. Here minus 2 to the power of 32 minus 1 to 2 to the power of 32 minus 1 minus 1. 2 to the power of 64 minus 1 to 2 to the power of 64 minus 1 minus 1. So let's see how to work with short now. So if you want, you can make it as what? You can keep this. If you want, you can comment, do whatever you want. You can do multi-line comment. This is multi-line comment now. Then you can start typing what? With short. Short S is equal to. Perfect now. You know how to write now. Yes or no? Short S is equal to 12. Valid. And I can print the value of short. Value of SS I can print. Value of SS plus yes. Compile. It will execute. Same you can type for what? Int. Nobody uses byte and short, don't worry. I'll tell you why also today. Technically we'll see why we don't use byte and short. Focus more on int and long itself. Understood now? You can work with what? Long also. Okay. So you can work with long also. Long L is equal to dollar. Sometimes see, you want to enforce this to follow long, take long type of value. So you can enforce it by putting L. Now this will become what? Error. Its value is 12, but it is taking what? 64 bits. It will be taking 8 bits. 8 bytes means what? 64 bits. So now it will give error. So this value you have to store it in what? Long only. So how will I do it now? Long L you can write. Long L is equal to, here also you can print L. Compile, execute. Perfectly it works. Compiler compiles it. So this was about whole number values I discussed. Similarly you can work with what? You can work with floating values also. So for floating values, so to store floating value, what is the value I want to store now? 12.679. I want to store some value like this. So you have to use a data type now. Which data type will you choose now? So you cannot store this in, see like this you see now, from right hand side I am trying to put it into a data type. Okay, so what will I do now to store? FLOAT, float, F. So you might think this is valid code. But the problem is what is the problem now? Precision problem now. It is taking double precision value. So each double precision cannot be stored in single precision data type, that is float. If you want to store a double precision value, you have to use double. If you want to use single precision value, you have to use float. Right now the type of value is the problem. The type of value is the problem. So to make it a single precision, I put the suffix F. So once you put the suffix F, so then it's not a problem. So you can say value of F is plus F. Again compile, it compiles, again execute, it executes. Now again, so it can be capital F also. Two things, either you can go with small f or you can go with capital F. So again I'll compile. Compiles, so this is single precision value. Single precision means they don't have high accuracy. They have a very less precision. So when you want when you're having small fractional values, then you go for like room temperature, some currency amount and all that. So that time you can go for what? Single precision. But if you are calculating something like sine, cos and all that, or which one? Pi, gi and all that, so that time you can go for double precision. They are highly accurate. Understood? So that time you can go for double precision. Anyway, this is a single precision. You have any doubts? So this is one way how you can write it. One more way how you can write the same code is say this: float F is equal to, you can typecast. But we don't prefer this. See the same output you'll get, 679. 679. There's no difference. But see, end of the day I made why am I typecasting? To convert it from double precision to single precision. So they are giving you two support. Means one you can do like this, or one you can add the suffix into it. We use the suffix type. But first of all we don't use float only, don't bother about this. First of all we don't use float only. Okay, you might have questions why you will not use. I'll answer it. Let's complete all this. Then we'll discuss why we don't use extensively byte, short, float and all that. Clear? Should I clear this now? Sorry, okay. We'll compile and I'll execute this. Perfectly it will work. So if you want to store, this is a single precision value. This is a single precision value. Okay, now we'll go with what? Double precision values. See, you also should type like this only, then only you'll understand your own code. Blindly what you'll do is you'll type everything without comments, see the output and go home. There is of no use. Until and unless you organize your code properly, you cannot learn. So the best way to learn something is self-learning. How much you learn yourself. Class is only guidance, but everything has to be learned by you itself. We guide you. Maximum what we can do is guide, but based on our guidance you will not learn everything. You have to put effort. So when you put effort, also put it in an organized manner like this. Double D is equal to, see this, 1, 2 point, same value I'll give. What will happen? It will compile, it will store, it will print, sorry, it will print also. It will compile and you can print the value also. Value of D is plus D. See, but it is compiling now. Perfectly it compiles because it is double precision and I am using the correct data type. So when you are storing a value, use the proper data types, else you start getting errors. Perfectly it will work. But as we discussed, this is standard notation. Single precision, double precision value with standard notation, yes or no? But I want to go with what? Scientific or? Okay, I'll show you this, which we are discussing till now. I want to store 75,000. 75,000 dot. Point 0. Perfect it is. 75,000.0. We are using standard notation. So let's compile. Let's execute. Perfect it is. This is standard notation. So now I'll show you with what? With scientific notation. SCIENTIFIC. Scientific notation. Same you can see now. How do you use scientific code notation values now? So I want to actually store 75,000. So instead what I'll do now in scientific style? E. What I'll do? E4. Perfect. Sorry, E3. Scientific E3. It will compile. See this. See this. This is a very important output now. What do you have to say? Perfect. It will compile. And what is the result it will give you? 75,000. Or I can also go with what? 7.5. E what? 4. Valid. See, it's compiling. So when you are giving values, you should know in where you have to store. Understood? This is, see, the data types form the pillar of programming language. They are the pillars. And how good you are with pillars, that bigger building you can construct now. This is a prime foundation what I am giving to you now. Don't neglect this. It looks very simple here because the way I explain, the way I code and show, everything will be comfortable. But when you sit to type, you will have problems also, you might get errors also. Okay, so type and practice from now itself. Else you'll face difficulty in the later stages. That time I can't go on explaining you these basics. I'll be moving into high level of programming. Clear? So practice this. It looks very comfortable. See this, check this now. Still the result is same. 7.5 E what? 7.5 E4. See the output now. Same it is. Or I'll make it as one more way I'll say. See, this is one way. I'll compare. Okay, we'll do one thing. We'll compare everything. It will become easy for you. E3 is also correct. 7.4 E4 is also correct. And double D 0.75. It can directly start with point also. No issue. 0.75 or you can write 0.75. That's your convention. 0.75 is also valid. 0.75 E5 is also valid. All will give the same output. Which one you want now? Start seeing. I'll go with the first one. So same 75,000 you can store it in multiple ways. Correct? First one is ready. Now second one. 7.5 E4 now. Perfect only. It compiles. You're getting the output also. 75,000 only. Last, which one? 0.75. See, this is valid. It will compile. At the same time what? Print the value also. Done? Okay. So now this is how you store this one. Or you can see one more last option I'll show you. You can go with just in case. You can go with what? Double D is equal to, you can start with 0 also. That's your wish. That is also correct. We go with 0.75 because it will become more clear. That's it. All are correct. 75,000. Same value, I stored it in so many ways. Clear? So what is 0.75 now? Mantissa. What is E? E and exponent. Mantissa, E, exponent. That's the syntax. So this is a standard notation. Top what you saw is standard notation. This is what you are seeing is scientific or exponential notation. We don't use this. We generally use scientific notation when the values are too small or too big. We don't use this, and it will be used in scientific applications. Generally it will be used in scientific applications. We don't use it in our normal programming. Okay, so if at all you want, still language supports it. Okay, if at all you want to use, still, see, Fortran was very good in writing scientific applications, remember? But it was not supporting some other type of programming. Basic is one more language. It was very good in programming, but it was not supporting scientific applications because their calculations need to be very precise. So these were the problems. So for one problem, one language was getting invented. So for such silly problems, why to invent a new language? Instead, Java language itself gives you all the support now. You want that, take this. You want this, take that. Whatever you want, it will start giving you. We as a developer will choose what to use or what not to use. These are the features of the language. Yeah. So this is on. So if you want to store a negative value, see, I want to store minus 75,000. Minus 75,000. Valid. Just add what? This one. Everywhere add a minus. That's it. So it will become minus 75,000. Now that is okay. But I want to store 0.00075 now. Let's see that. I want to store some value. See, here it was 75,000. Positive or negative, secondary. Now wherever I want, I can put negative here. So it will become what? Minus 75,000. Yes or no? All are correct. But now my requirement changes. I want to store what? I want to store, the value what I want to store is different now. This one, see this. First I show with this. Double D is equal to 0.00075. So this is standard notation. Again, this is standard notation. Again I can print this. Standard notation, only one style you have, and it will print. There is no difficulty in this. See, standard notation. Compile, it will execute. But it prints like this. E minus 4. Sometimes when you see values like this also you should understand. If it is small, it will print off very clearly. See, 0.0075. It will compile. Now you will say this is okay, but as soon as the value starts exceeding, see, 0.0075 prints as it is, but as soon as the value starts exceeding, what it will do? It also cannot hold and print it. So what it will do? It will start using scientific representation. See this? E minus 4 it started printing. Understood? So then I'll store this one. So what it will do? I'm showing you still standard. I'm storing it in standard, but while displaying it is giving me in scientific notation. So as the numbers become bigger, language will automatically do this. Okay, fine. This is done. So now this is standard notation. Okay, but if I want to go with what? Double precision. Fractional value standard notation, standard style, standard notation. Done? This one is this. So now I'll go with scientific notation. Double precision fractional value scientific notation. So we'll see this. Scientific notation. So double D, see, we'll see it with scientific notation. How will you see it with scientific notation? You tell me now, how will you write this? I want 3 zeros. Huh? How do you write it now? You can write 7.5 E minus 4. That's it. You just saw the output itself. Same thing now. So this is how you can store the value. Understood? It prints like that. E minus 3 will print you very interesting answer. What will print? It will print 0.075. If it is small, it will print it off, but if it is big, it will also print it in the same way. So if I write minus 2 also, it will print what? 0.075, 7.5 and like that. Okay, but if I give a bigger value like 9 and all, it will also print it in the same way. Done? So this is how double precision values can be stored. Clear? So then if you want, this is done. Then next I'll go with char values. Are you clear with the byte, short, int, float, double? Typecasting I'll come back. I'm only going with data types now. I'll go with what? Char now. Or for that, what you can do, data type demo, no? Okay, you can again a better name. Okay, this is data type demo. I'll go for one more file now. A new Java. You can create more files. Character demo. Done. More files you can go. Character demo.java. Very simple program now. Check whether this program works. Control 1. Control 2, it is working. Don't type everything and compile and execute, you will never learn. Step by step, type, compile, execute, type, compile, execute, go on learning. And anything you notice, identify, comment it. Tomorrow when you visit your program, the moment you write your comment now, it is as good as writing in your book. And you know, writing once is nothing but what? Reading 1,000 times. Understood? So better you practice like this, else you will not understand. They are very simple, only you make it complicated. See, we are learning Java now. If you want, with these basics you can go and learn C also, na? With these basics you can go and learn C++ also, na? So you are thinking, to learn Java, C is required. Now what is happening? After learning Java also you can go and learn C more clearly, no? It's all the same. So one language you should put effort and learn. Once you learn one language, other languages will automatically become very easy for you. One language you have difficulty. Okay, any language you have to struggle. It can be C or C++ or Java. But let us struggle in a language which we really want to use throughout our life. Instead of learning C, C++ and struggling, let us, because we have decided we are going to devote our life for only Java programming now. So put effort and learn this language only more clearly rather than putting effort in C, C++ and all that. That's all. So now see, it is working. Char x is equal to, I'll write A. Sorry, you give what? Single quote. And I can print system.out.println. What I'll print? X I'll print. So what will be the value? Semicolon I have to give. Your favorite error? Yes, sir? Semicolon comes means you have full question. What? One great error you have detected. Okay. So compile it, execute it. So it prints A. So clear with this? If you want to see this, very interesting. X plus plus. So now can you guess what is the output? They are incrementing it by 1. So they are called as increment operators. Operators are not covered, but I'll be doing it later. But end of the day, 65 becomes 66. See here, I am writing char x is equal to A. I am writing it like that, no doubt. But when you write it char x is equal to A, internally how it will be stored? 65. Remember that. Internally it will be stored as 65. Understood? 65 means it will be using what? As Unicode standard here. In Unicode, for A, they are having the value of 65. But again, 65 will be converted to binary and stored. You don't worry about all that. Just learn to use it. So this is done. So now when you increment it, 65 get converted to 66. And 66 value is nothing but what? B. As simple as this. Clear? Or you can say x is equal to, instead of writing this, you can say x is equal to what? X plus 1. This also is valid. Same output you will get. But increment operators I'll teach you later. I are not covered operators. That's the next topic. X is giving error. Okay, I can't do like this. It says you have to use increment operator. Means here what is happening? X plus 1. Why it was giving the error? Can you guess? So you are using a plus operator. Plus operator is used for what? Addition or concatenation. Addition or concatenation. So x is character and 1 is integer. So you cannot add a character in integer also, nor can you concatenate character with integer. So that's why it's giving you error. Understood? So like this, when your basics are very strong, you will understand why you are getting the errors. You will understand. See, when I am taking the class, you might get a lot of questions. What if I do like this? What if I do like that? But if your basics are strong, you'll start getting the answers to yourself. You understood what is the error now? See the error. Sorry. X plus 1 now. Anyway, I have not taught you plus operator. I have not taught you plus operator. Plus operator can do only two things here. One is it can do concatenation, one it can do addition. If both are int or numeric type, it will do addition. Not only integer, float and float, it will do addition. Both are numeric, it will do addition. Both are string, it will do concatenation. One string, one integer, still concatenation. But char and int, it cannot do anything. So I will give this error. Clear? But anyway, you can do x plus plus. This one, the increment operator, what I can use? Fine. It prints. I didn't increment it. Okay. It is anyway, it becomes what? Post increment. First it will give the value and then it will increment. No. So let's not worry about that. Here what was happening is x is equal to means what? First the value of x is given to x, then it will increment. Understood? So I am printing which x now? This x. So it will print a only. So don't worry. See, these are your very tricky interview questions. These are how they ask interview questions. And you'll understand that output after I complete operators. Still operators pending. I will teach you that. There it will become very clear to you. So we are right now learning data types. Just see now, it will print B now. Clear? Don't worry about character. It just uses, Java uses Unicode standard to store values. Java is using Unicode for supporting what? Internationalization. That's all you bother. And we never use char data type. Done. Next we'll go with Boolean. File new. You can go on writing your programs like this now. So now see, the class names are given so neat and clean. Because tomorrow when you see your program now, you should know what it contains. Understood? If you give your class names like A, B, C, hello, demo, hi, welcome and all, what will happen later? You will start seeing your program, it will start telling you hello, hi. No, imagine. The programs will tell you hello, hi, welcome. Understood? So give good names to your classes. Your mummy and daddy have given you good names now? Did they name you as A, B, C, D? No. If anybody calls you A, B, C, D, how will you feel? You don't like it. Okay. Similarly, when you are giving name to something, you should give it professionally. This reflects professionalism. So give good names. Clear? So boolean demo.java. Clear? So now next. Boolean. See, the actual value what I want to store is true now. The value what I want to store. Now this cannot be stored in float, char, double and all that. So I have to store it where? Boolean. System.out.println. So can you guess what it prints now? True. It will not print 1, 0 and all here. So whatever the value it will print. So if I want, I can make it as b is equal to false. I can overwrite it now. Okay, so b is equal to false. Now what will it print? Compile. False. Fine. Now if I want, I can write some logic. If else if b system.out.println, you can say welcome. Else not welcome. So what will be the output now? Welcome or not welcome?
Not welcome.
It will be not welcome. See, if false it is. So when you are using boolean with if block now, remember, see, the if block should be evaluated to true. That's the rule. Means when you are having if and else condition, which is evaluated to true, that gets executed. Sometimes if will get evaluated to true, sometimes else will get evaluated to true. Either of one will execute. But which one gets executed depends on which one is getting evaluated to true. Now if condition is becoming true, false means obviously else will become what? True. true. If becomes false means this has to become true. If becomes true means else has to become false. If becomes true, else is false. If becomes false, else becomes. As simple as that. So if false means obviously else is true now. So now else part will execute. Not welcome will print. So this also I'll comment other things. So in interview, you have a very good habit. Whatever is welcome, you start saying. Means whenever you see the welcome output now, you'll go with that option. Don't think always it will be welcomed. Understood? So see this. So it prints not welcome. But the same, I'll negate it. Anyway, these are all operators which I have to teach you. Later I'll be teaching you. If not be, what will happen now? If not false is true now. Yes or no? If not false means obviously if condition is becoming what now? True. If this is true, if is true means else become false now. As simple as this. Okay, now till now what was happening? Boolean B was false. But now I'll make it to true. See this change. B is, now don't write capital true. It will not work. Understood? So you have to go with, see I told you it's not a keyword but it's a value. So you have to use this only, true. Now see, if not B, what will happen? If not B means this becomes false. So obviously now which one gets executed? Else condition gets executed. Understanding now? So if not true means obviously this becomes false. If becomes false means else becomes true now. As simple as that. You just see which one is becoming true, man. Just see which one gets evaluated to true. See also the same story, but they use 1 and 0, which is more complicated to understand. They use 1 and 0, or you can say, can you use 5 also there? If 5, if not 5, anything like that you can use. But here it is very clean. And you can understand it very easily. In C and all it is very difficult. If not 5, if 5, like that and all you write. Okay. So but here it is very clean. If true, else false. Means if true becomes, if block becomes true, else block becomes false. If is false, else becomes true. As simple as that. Cannot find symbol. You have to declare it now first. I had commented there on top. Boolean B is equal to true. Okay. Not welcome. See, even though it is true, here it became what? False. Now I'll remove this. Now which one? If becomes true. So welcome will print now. See, this is very very tricky. They'll give plenty of questions in SCJP on this Boolean value. Remember this. Clear? Work a lot on this. Be very perfect. But it's a very simple calculation. What is getting evaluated to true, that gets executed. Nothing to bother here. What gets evaluated to true, that gets executed. That's it. It sometimes if can become true, sometimes else can become true. That's it. Which one is true, which one is false, you have to have the idea to guess now. So fine. Now one more thing. What is that? We saw the outcome of a relational operator can be what? See, sometimes we will be needing values like this. See, I want to store what is the result of 10 greater than 9. I want to store this value. The result of this I want to store. Can you store? C is giving you the support for storing only what? The result of arithmetic operators. C is not giving you the support for storing the result of what? Relational operators. That's the problem. Java gives you this and you can use it here now. What I'll use? Okay, Boolean B. I'll just directly I'll comment it here. Here I can write. Valid. 100% valid. And you can guess what is the output here? True. And here I have hard coded. Sometimes it will be like this. You will be writing int a is equal to 10 or int I will take. I is equal to 10. Int j is equal to 9. Now what will happen? Just substitute the value. I and j. Like this, they will become dynamic later. You understand? So the result I and j. See, I plus j I can store it in int data type. When you are doing an operation, see, if I am doing addition operation, then I can store it. The result is what? Int. If I'm doing addition operation, I and j, if I want to add, I'll store it where? In k. But when I'm doing this operation, what? I greater than j, that time I have to store it in what? Boolean. Boolean k or anything you use. Clear? So anyway, operators, expressions, next topic. I'll be covering that. Clear? But just I showed you how you can use the Boolean data type. Boolean data type is used for storing what? Only two values, true and false. Okay, you cannot store any other value here. Are you clear? And now see, I'll just show you if you want. Boolean B, I'll store what? Some of the common mistakes, 10. What did you give? Error. These mistakes don't create. These kind of mistakes you should not do. What will you get now? Incompatible type. But what will you be searching for? Semicolon. These are your mistakes. The error is something, but you are looking for what? Where is semicolon missing now? Understood? So you cannot code like this. Your mistake is something and you start searching for semicolon and then tell what? Language is difficult means who will ask? Means it's a wrong thing, no? Generally what you do, program should compile for you. If it compiles, it's an easy language. But remember, C also compiles and every time you'll restart the computer. Here till now that thing has not happened. Understood? So it's a very robust language. More things are checked during compilation, more errors you get during compilation. How many errors you get, that is beneficial during runtime. And don't sit on looking for what? Semicolon. You should be very precise. What value you are giving to what data type and all that. So is Boolean clear for you now? Char over, Boolean over. So do you have any questions here? I'll go with typecasting. Okay, then if you have any questions, you can ask. So next we'll go with typecasting. So you can close all this. File, new, Java, typecast, demo. Or you can have two files. In one file only you can type implicit typecast demo, explicit typecast demo. It's your wish how you organize. Just I'm giving the idea how you code. Okay, so I'll do both the cast part in the same file. If you want, you can have two files. Typecast demo.java. Now, first byte b is equal to 0. Int I is equal to 0. Or I'll give the value. Byte b is equal to 5. Byte b, say while declaring only you can give the value. Byte b is equal to 5. So now, if I print, it will print. There is no issue. Value of b is value of 5, both it will print. What it will print? So there are two values, 5 and 0, and I want to store it. I have stored. Where I have stored? One I have stored in B, one I have stored in I. It will compile because see, type of value, range of value, everything is correct and they are getting stored. So it will be stored. And it will print the output also. But there is a requirement now. I want to give the value of B to I next. So I can give it. How will I give now? I is equal to B. Perfect. And this itself, what will happen now? After these two, you can, means now I can cut, I'll cut this and put it here, code. So after giving the value, one second, I'll let this remain. So this is actually called as implicit casting. Or what? Or widening conversion. Both are correct. Done? Perfect it is. So the value of B is now given to I. See this. Earlier I value was 0. See here. First time it is 0. Next time it is what? 5. Who is taking care now of implicit casting? Runtime. The runtime itself will take care of implicit casting. You don't have to worry too much about this. Yeah? And there is no loss of data also. Is there any loss of data? Because always will be giving, why there will be no loss of data? Because you are giving smaller value to bigger data type. Definitely it will be within the range. So you will never have a loss of data. Yeah? But the same if you try to do ulta now. Okay. What I will try to do now? Okay, we will comment all this now better. byte b is equal to 0 this time, int I is equal to 5 this time. Perfect. Understood? So here what happens? You are trying to use the value of what? I to b, and this becomes what? Explicit. Yes or no? Or narrowing. You are narrowing the value now. 32 bit you are making it to 8 bit. This has to be done explicitly by the developer. Understood? See this, it will give error now. Possible loss of precision. Compiler is warning you. What value you are giving to what data type during runtime will get error. Better now only you are getting the problem means. At least you can resolve it. If this problem, if in C and or in other languages what happens, it will store. And runtime it will start giving you problem. Understood? So what we can do now? Means this will not work. So what you have to do? For doing that, see explicit casting is this now. This line is explicit casting. B is equal to byte of what? I. What is the syntax? What is the syntax? Destination is equal to target type then source. This is the syntax. You know the syntax. Perfect it is. You are telling the compiler, I know this is going to happen, but still do it. Only if you force it, then compiler will allow it now. By itself the language is not allowing now, but you are forcing it to do it. It will do it now. So that's why it's called as explicit casting. And the value here it will not affect. Why it will not affect? Why it will not affect? Because there is no loss of data, because it is within the range. But the same if I make it bigger, 130, yes, it is outside the range now. So here there is possible chance of loss of data. See, minus 126. I remains same, but the value in B is changed. I value will not change. The value of I was given to B. While storing in B, the value is changed. Clear? Any questions? So what all questions you have in typecasting, ask now. I'll solve all your problems. You want to give float to double, double to float, yes sir? Is this basic typecasting clear now? Yeah, well, if you want you can continue coding now still. See now, I'll have int A is equal to 10. And I want to give it to float F is equal to 0. First of all, check whether can you give 0 to F. Will give error. No, for 0 it will take. For storing value of 0, no issue. But if I try to give a value of 1, it will be single precision. Now this is also storing. Oh, okay, it's taking as integer value. Yeah, it means if you give a whole number value, directly it will be stored in what now? Float. If you give implicit casting is happening, nothing else. Implicit casting is happening here. 123 will be typecasted, converted into floating value and stored in float F. As simple as this. But if I give a dot finished, it will be taking it as double precision. Understood? It will be taking it as double precision. So now this will not compile because it's taking it as double precision. So now we got the idea that int will get converted to float implicitly now. So now if I want, I can store the value now. Anyway, see float F, I'll make it as 0 only, and then we'll print the value if you want. Yesterday we had this question now. I'm just clarifying that doubt for you now. Compiler will teach you, man. Very clearly the compiler will teach you. See now, as I go on teaching you this subject, it will become boring now. It is, if you learn it, it becomes interesting. If you do it by yourself, it becomes more interesting. So fine, it compiles, it executes, 0.0 it prints. Now I want to give the value of what? Into float. This will happen implicitly now. No issues. And what will F print now? This is implicit. Both are 4 bytes, but the type of value will get changed, and there is no loss of data because it's within the range. Done. Then, but if I do reverse, int a is equal to 0, float f is equal to 5. Float f is 5 now. So let's see now. And I have to give what value to what now? A I have to give, means f value I have to give it to int. So let's see. So floating value cannot be stored in whole number data type. So you have to do typecasting. That is implicit. This is explicit. So you have to make it as int. Done. So in int it is 5. As simple as this. Similarly, you can go on doing conversions. Double value I want to store in int. Here I tried with float. You can change this to what? Double and try. Now when it is double, there might be loss of data because the double value is too large, and if you are trying to put it into int, you are putting 64 bit into 32 bit now. So that time what will happen? You can see now. But see, one more thing. If it is float, just see this 5.908. Here loss of data is there. Why loss? What data will be lost? The fractional part of the value is lost. Loss of data is there now. Even though, means in explicit casting always there is a possible chance of loss of data. Only in explicit. Depends. So now say, it means you have to make it what? F. Because it is double precision, make it F, it becomes single precision. Now there will be loss of data. So what is A printing now? 5. First it is 0, then F is this one, then A is this one, then F is 5.908. Clear? Clear this? See this output, you see the last but second output from the bottom. Last but of second output from bottom. Value of A is what it's printing. Compare it, man. First one A is 0, second time F is after initializing. Then after typecasting A is 5, this one. Same thing will happen for what? When you are giving double value to int. No change. Here I am taking single precision value and storing in int. You can store double precision value in int. Hardly any difference. Clear? Can you try that out? So you should be very comfortable in all these data types. So yesterday whatever I covered I typed and showed to you now. If you have any doubts, ask. Any doubts? Ask. Clear? So now see, we are putting so much of effort in learning these data types. One good thing in Java, shall I continue now? Next part, today's subject I start now. See, we put so much of effort here in learning all this. Okay, and it's worth it. It is worth it. Okay. Why? Means, one second, I'll cover one more example. See one more, then I'll come to that. One more topic. See here, what happens, sometimes, see one more program we'll see now. Int, public static void main. Now see, this values what you are having now, when you are using them in an expression, I have still not thought the expression, which there I'll be doing more in detail. When you are using it in expression, especially what? Addition, multiplication. Okay, so see this, PSVM, all that is there. See, byte A is equal to 1. Byte B is equal to 2. I am writing two values. SOP AB, it will print perfectly. There is no issue. What will be the value of A and B? 1 and 2. Perfect it is. No doubt about this. Okay, because they are within the range, type of value is correct, everything is okay. But now I'll try to use it in an expression. This is what addition expression. So when you're trying to use it in addition expression, what happens? Okay, the result is 3, but I cannot store it in byte. I cannot store it. Byte A is there, byte B is there, byte C is there, is equal to 0. SOP A, B, C, what it will print? 1 to 0. Correct? Huh? So, but the same if I say C is equal to A plus B, now it will give you error. It gives you error. So, see how good you are in data types, it becomes that much better in writing future programs. So this gives you error. It will not work. Why, can you guess? See, in Java what happens is, when you are evaluating, means when you are using the data types in expressions, when you are using the data types in expressions, the data types get auto promoted. Auto promoted means if they, especially when the value is of type byte and short always get auto promoted to int type. They'll take 32-bit form now. While storing, no problem, it will be in 8-bit, but when an expression is getting evaluated, they take the form of what? Integer type. They get auto promoted. I am not doing the conversion. I am not doing the promotion. Who is doing the auto promotion? JVM, runtime environment. So actual value is 1 only. The value is 1 only. Value of A is 1, value of B is 2 only. But A is now in 32-bit, B is now in 32-bit. Addition will be performed. 3. Now 32-bit cannot be stored in what? C. That is the problem. So in Java, when an expression is getting evaluated, the byte, short and all that, they get auto promoted to int. Int will remain as int only. Okay, so what gets converted to what? We'll start seeing. Just see this. So now this will not work. So if you really want to store this, I could have used one int. This is one option for you. Int z is equal to a plus b. Result is 3. Now 3 can be stored in z because what? It is within the range. Type of value is correct. But most importantly, size. Most important is size. It's 32-bit, I can store it in int also, or I can store it in long also. No, but the result, I want to store it in byte only. That time what will you do? Typecast. As simple as that. So how will you typecast now? C is equal to byte of a plus b. Put braces here also. First a plus b will happen 3. Now 32-bit will convert into what? 8-bit. And now it will be stored in C. So now if you print SOP C and Z, result is same, no issue. But C is of type byte, Z is of type int. So whenever an expression is getting evaluated, like byte plus byte, both will get converted to what? Int. So whenever an expression is happening between short and short, both will get converted to what? Int and int. But whenever an expression is getting, this thing is happening, both will be int. So minimum they get converted to int when an expression is getting evaluated, or sometimes the case might be like this, byte plus long. Now byte will get auto promoted to long. So byte value is definitely converted to minimum int or to the higher side. Minimum int to or to the higher side, byte and short. Okay, now what happens, see this one also int, so this one will become long, this one also will become long. But what happens when, you might have questions now, why they are doing this? I'll give you the reasons, but just see how it works now. Suppose I am doing an addition between int and long, what will happen? Int will get converted to long, this will get converted, this remains. So minimum to int or to the higher side. Minimum to int, or it will be taking the higher side. I'll give you a good example itself. Okay, so this is how it happens. So here both bytes are getting converted to what? Int, the result is 32-bit, 3, and then it will be stored. Now why they are doing this? There are many reasons. One of the reason, see this. Supposingly, I am writing one big expression here. I'll take int byte A, byte B, and I'll take byte C is equal to 50, 40, then I'll divide it by 100. Okay, let's see. C is equal, see another program this is completely another program. There are 3 values. If you print it, it prints fine. Then I want to say A into B divided by C. Okay, means put brace. You have to put brace. About parenthesis, hierarchy of operators I'll teach you. First hierarchy preference is given to multiplication, division. So that's why I want division is given. You know BODMAS now? Operators topic is pending, I'll teach you there. First preference is given to division, but I want which one? Multiplication to happen first. So increase the precedence by using the brace. So first it will multiply 50 into 40. See value is correct, 50 and 40 both are correct, but the intermediate result what you get now? The intermediate result, understood, the intermediate result is 2000 now. Now where will 2000 be stored now? It is outside range. Divided by 100 is how much? 20. Correct, but the intermediate value when you are evaluating, where it will get stored? So this becomes a problem now. So that's the reason what they do is they auto promote this to int now during an expression. So this is one of the reason. One of the reason is this. And one more thing is, see many operating systems in the world, okay, you cannot store it in what now? Now int z is correct. or you can typecast and store it into byte. This you can typecast. How will you typecast? Byte of byte Z you can write. So this is one way, or you can write it as int P is equal to A into B divided by C. This is also correct. Sorry, A into B divided by C. See, here I multiplied, then I divided, then after doing all this operation, then I am converting to byte, storing it in byte. Understood? So if you want to really store it in byte, here loss of data will not be there. Why? It is within the range. 50 by 40 is 2000, 50 into 40, 2000 divided by 100 is 20, it will be stored. If it is outside the range, definitely there will be loss of data. All these rules what you studied will be applied. It becomes very easy now to see, write logics, it becomes very easy for you. See, now all the operating systems in the world do not understand this byte and all that. Okay, so that is one reason. What happens during one, there are two reasons why they are auto promoting what byte and short to int. One of the reason is the intermediate result might exceed, or it might have a big value. That is one reason. See, why they are auto promoting what byte and short to int is, there are two major reasons. One is the intermediate result will have a very high value. Second thing is, all the operating systems in the world do not understand what is byte also. But Java is talking about portability now. Understood? Java is talking about portability. Due to these two reasons, what they did, they are auto promoting byte and short to int. Two reasons. One is what? First reason is what? Intermediate result might be, intermediate result means result into, what do you mean by intermediate result? Something like this, A into B, 2000 it is. Intermediate result will have higher value. That is one reason. Means if your question is why byte and short are converted to int. Converted to int when? During an expression. Only during that time it will be converted. When you are storing it simply, it will not convert. Understood? Second reason is most operating system do not understand byte. Some don't understand the short also. Many of them understand, but byte they do not understand. Most operating system do not understand byte data type. But Java has to support what? Portability. Due to that reason they will do this. These are the two reasons. Might be more reasons are there, but I am talking about more important reasons. Clear? Fine. Now let us take on all the values now and try to evaluate. You'll get the clear idea. I'll give you some more examples here, you'll understand. So let's come back to this program now. After teaching this, I'll type and show it to you. Don't worry. All this I'll type and show it to you. First, let's go with simple programs. See, byte A is equal to 5. Byte A is equal to 5. Int I is equal to 6. Yeah? So I want to add now A plus I. What will happen? Byte will get converted to int. Result is what? Int only. So you have to store it where? Int P. Int and int now. This is one example. This is one example for what? Byte with, I'll take like this. This is an example with byte with what? Int. Now I'll take an example. Byte with byte you saw. Byte with int you are seeing. Now I'll go with what? This is byte with int. Now we'll see one more example. We'll see what? Byte with long. So byte B is equal to 5. Long L is equal to 9. B plus L, what is the result? Long. So minimum to int or to the higher side. Long P. So this is byte with long. This is second scenario. More scenarios you can take. I'll take int with long. Int with long. Minimum. See here, minimum to int or to long. So int with long now. So int I is equal to 5. Long L is equal to 9. I plus L. What is the result? Long. Now int is also getting converted to what? Long. Understood? So result will be long P. Long P. Result. Long with long itself. Int with long, int gets converted to long. So this you saw with whole number. Now what happens if int is added with double? Int gets converted to double. Long with double. Long gets converted to double. Higher side. Whatever is higher? Minimum int man, all to the higher side. As simple as that. Float with double. Float will get converted to double. As simple as that. We'll see examples. We'll understand. Now see, we put so much of effort and learned all the data types. How they are working. It really pays off. It really pays off. What is the behavior you are learning? Your Java is portable. You take and run your program in any operating system, you'll have the same behavior. But this is not true in what? C language and all that. Okay. C, int will behave in one operating system in one way. Int will behave in another operating system in another way. So there it becomes a big headache. You'll put full effort and study into there. Understood? To study on data type, you know how much of effort you have to put. It's not so easy. You'll put the effort and study int, how it works, what is it, how it is storing, all that you'll put effort. But it will depend again on operating system to operating system. In Windows it will work in one way, in Linux it will work in one way, in Macintosh it will work in one way. You can't predict the value only. First of all in C, junk values are getting stored. First of all in C, if you don't give the value, what will be happening? Junk values are getting stored, garbage values. On top of that, the behavior also you can predict. You cannot predict. But here, whatever behavior you are learning is clear. Whatever effort you put here is going to pay off. So, you know, data types are the pillar. But there is so much of problems in those data types. Understood? I am not saying C is bad. C is also good as compared to which one? Binary and machine level language. C is good. But there are some flaws. But when this new language was getting invented, it's a refined language. I keep telling you, Java is refined. Whatever the problems they faced in different languages, they eliminated all that. So how your data types behaves in one operating system, same way it will work in other operating system also. That is one great benefit in Java what you get. So the behavior of the data types in Java is standard. It does not change from operating system to operating system. The behavior of data types in all operating system is same in Java. Whatever you are learning now is same. You don't have to worry. Understood now? But in other languages, C is only an example I am telling. Don't think C is bad. Pascal also might have the same problem. COBOL also might have the same problem. But they are having problems. Okay, the data type might change. The behavior might change. The value might change. We can't predict. Clear? So that's the idea. So I will type and show you this. And you understood why they are doing all this auto promotions? Auto promotion clear? Clear? Only for these two main reasons. These two main reasons they are doing the auto promotion. So I'll type and show you all this code now. Okay. But before I go, one more last program we'll type and see. Means I'll write and show you. Then I'll start typing. See this. I'll have byte b is equal to 1, short s is equal to 2, int I is equal to 3, long l is equal to 4, float f is equal to 5.0 f, mandatory. See now code you are understanding now? So clear it is. Double d is equal to 6.0. Understood? These are the values. So I want to do some mathematical operation now. Let's find out what is the result you get. Clear? So I'll write something like int into byte plus short multiplied with float divided by long second. Int into byte plus float I'll take multiplied by short divided by d 1 2 3 4 5. Which is the other one? Long, no? Okay. I'll multiply that also. See, sorry, I'll use minus here. So I am trying to multiply, add, multiply, divide, subtract. All the 4 operations I am trying to do. Okay, see there is something called as BODMAS. This comes under hierarchy of operators. Operators I have not covered. In depth I will teach you. But just one simple evaluation will see how it happens. Because the here I am concentrating on what? Auto promotions. I am not concentrating on operators. Okay, so first according to BODMAS, which one will happen now? Division. Then what will happen? Multiplication. Then what will happen? Addition. Then subtraction. You know this? So let's start putting now. So this is a big expression now. Internally how it gets processed. So first in this expression, which one gets evaluated? Division. So the division which is between what? Short and double. Yes or no? So it is what going to do now? 2 divided by 6. It will divide 2 by 6. Now 2 gets converted to what? Double. That intermediate result will be what? Double value. So some value will be here. Okay, I think we'll divide it by 1 second, which will be easy for us to calculate. I'll write the expression in that way. So we'll divide int by short. Okay, it will be easy. So then what is the result? I by minus or plus, I'll add double minus byte what is the other one? Float and long now. F into L into F. What is pending? 1 second. Okay, we'll take like this. So let's see this now. First is what? Division. According to that now, see I just changed it, int and short. So you are dividing int by short. What is int now? Oh, again it is a 3. Okay, fine. 3 divided by 2. Again. Huh? Change my okay. So I'll make it as 30. Okay. So now 30 divided by 2 is what? 15. We will take it like this. I will change the value of int. It is 30. So it is 2. So now after division, next is what? Multiplication. So there are 2 multiplications. This side on multiplication, this side on multiplication. Which one will be happening first? Left side to right side or right side to left side? Left side to right side. Evaluation always, evaluation of an expression always happens from left to right. Means like this it will go. Assignment happens from right to left. Means see, this is assignment. After all this evaluation happens, then this value will be assigned. Assigning is different. Understood? Assigning is what? Giving the value. Giving the value. So that will happen from right hand side to left hand side. But evaluation will always happen from left to right. So based on that, what is the result here got here? 15. No? So then is multiplication. L into F. So long gets converted to what now? Float gets converted to long. And then it will be multiplied. What is the result? 5 into 4, 20. Okay, then minus I. It will divide. Sorry, then again this one now. 15 into double is how much? Now 15 will get converted to double. Like this it goes on now. Understood? And finally the final result will be what? Double. The final result will be double. So if it is within the range, it will store it. Fine. And definitely it will be within range. Man. Okay. So then it will store it. But if you really want to store it in byte, you have to do typecasting. Because the result is double. We are not talking about range now. The result is going to be double. So let's see it with an example only. I'll type and show you this. All these programs you will see now. Okay, we'll come to a program. So we are seeing file. We have to see auto promotion. So auto promotion demo now. So first I'll go with simple things. Byte A is equal to 1. Byte B is equal to 2. Byte C is equal to 0. Value of A is, you can print all the values. I have to save this. Okay, it compiles. Now you can print all the value. A, B and C will print. Now no issues. It's still stored as what? Byte itself. But when the evaluation starts off, or when you are using it in an expression, both of them will get converted to int. C is equal to A plus B is error. Let's try to print this last value. See this. Initially first I'll compile this and show it to you. It compiles and it prints me 120, no issues. But now at the moment I start doing addition, so it says error, possible loss of precision, because they are getting auto promoted to int. So now if I store it in int z, no issue, perfectly it will print now, and I can say value of z is plus z, perfectly it will compile and work. Perfectly it will compile and work. Okay, but if I really want to store it in byte itself, so that time what I have to do? See, C is equal to A plus B is error, because auto promotion has happened. But if I really want to store, that time I should say C is equal to byte of done. This I can do. So again I'll compile, again I'll execute. Perfectly it will work. Okay, then I can print value of C also. I can print both. Value of C is plus C. So they are getting auto promoted. Why they are getting auto promoted? Two reasons. One is what? Intermediate result might have a very high range. That is one reason. Second one is they want to have portability. Many operating systems do not understand byte and all. Yeah? So these are the two main reasons. Fine. You don't bother about that. Just you understand how to use. And first of all, see, anyway, now this is the main reason. Anyway, byte is getting converted to int only during an expression. So what is the use of storing your values in byte now? So blindly we start using what now? Int only everywhere. Understood? Blindly we start using int. Don't bother about memory. Generally, if I write int I, you'll think, okay, 4 bytes memory wasted. First of all, you have hardly not, means you have not even written the program only. Hardly you have written one line and you start talking about memory. First write an application. Your application requires how much memory, anybody can sponsor that. Understood? Your application requires how much of memory, anybody can give that to you. Okay, they can sponsor it. But you don't write code only. Instead of writing code, what will you be telling? Int I 4 bytes, byte B 2 bytes. Like that, if you start telling, what is the use? First write your program, then tell how much of memory is required. Today they can supply any amount of memory. So don't bother about memory. Okay. So that's the reason we never use byte, short, all that we'll not use. Standard, always we go with int, long and double. Only these 4 we'll use. Sorry, only these 3. Int, long and double. For whole number we use int and long, and for fractional values we'll be using double. That's it. So don't bother about other data types. Char also don't bother, because we don't store single values. We store multiple values, and for that we'll be using string. But I just showed you the support of the language. See, generally we complain, no, C is not having this, C is not having that. That complaint should not be there. So that is why language is very rich. It gives you the support. It is left to the developer to choose what he wants for programming and leave what he doesn't want for programming. See, when you buy a TV, when you buy a car, what do you look for? Example, TV you are buying, you look aux input, or what, so many input you look. USB support, this support, that support, everything you look. Finally, when you bring the TV to your home, what you will do? Two buttons only you'll be using. One is change the channel, second one is change the volume. That's it. Apart from this, nothing you will do. So, but while buying, everybody will think about what? This option, that option. So similarly, before you learn the language, you look into all the options. But finally, what options you use is going to be very limited. But you need the support. In case if it is not there, tomorrow you should not say it is not there. So that's why they'll give all the support to you. When you buy a car also, you'll ask what? AC, if this thing, that thing and all, you'll ask. Okay, you'll ask. But once you get the car, hardly you'll do what? You'll drive. That's it. You'll not be using maximum features of that. But that's why when buying and all that, what we do more research and pick the best one. Similarly, here also you are learning something because you have to put a lot of effort. So you have to choose the best one. Language supports you with all this, but it doesn't mean that you go on using everything. Understood? So these are the features of the language. So this is auto promotion now. Yeah. So next you want to convert into what now? I'll directly do it off now. What I'll do? I'll do byte with int now. Byte b is equal to 10. Then int I is equal to 5. So here what is the operation between int and byte? So directly the result is what? Int z is equal to I plus b. Fine, valid. I will print value of z is. Whatever conversions you want, you do now. So here what is happening? Byte will get converted to int. 15. Perfect it is. So now if I want that anything now byte and int, I'll change this to what? Long. Now byte will get converted to what? Long. The result is what? Long. I cannot store it in int. Check that. It should be stored in what? Either long or typecast and stored. You have to do explicit casting here. Clear with this? Any questions, sir? So if I want to store it in double, byte will get converted to what? Byte will get converted to double. See, I'll store it in what? Double only I'll store. Byte is getting converted to double. It will compile, print. Now I want to do operation between int and double. Now int is getting converted to what? Double. Int gets converted to double and the operation will happen like this. So minimum to int or to the higher side. Clear? So now if you want, you can do that which one program also. So we'll write now which one? Byte b is equal to 1 short s is equal to 2 int I is equal to 3. Okay, we'll see it. Int then long now. Long L is equal to 4. Float f is equal to I'll give 5.f. Long L is equal, double. D is equal to 6. So now we should start doing the operation. I'll do one thing. I'll divide for long with. I'll try to manage within this long with short. I'll divide. Clear? What is the result? 2, no? Now short gets converted to long. This 2 into I'll do 2 into double. So it will become 12. Now minus what I'll do with byte I'll do. It will become 1 is 11. Then we can do what? Addition. Plus I'll do. And last one is what? Float. But what operation is pending? Multiplication into float. This is the result. Okay. But what happens means you can so first according to BODMAS you can write the expression anyway. First what will happen? Division will happen. So L into S, division. L divided by S is how much now? 2. 2 into D is how much? 12. But that result is getting converted to double, 12. Then minus B, 11. Sorry. This is 12. First division, then multiplication. This multiplication, then this multiplication will happen. I into F. Now I will get converted to float. So it will become 15. So till here what is the result? 12. Here what is the result? 15. Then addition will happen, no? So 1 plus 15 is 16. 16, then here this side what value I got? Well, I think it will be minus 3. 3 or 4, something like that. Clear? So let's see the result. But the result is in double. You have to store it in double. So value of Z is, you can print it. You cannot store it. No need to typecast. Okay, value of Z is 26. It means sit and calculate, man. What is that? L by S is how much? First is division, no? Huh? L by S, long is 4, divided by S is how much? 2. So this is 2. Then multiplied by what? D is how much? 6 minus B is what? 1 plus I is what? 3. Float is 5. Okay. So then next will happen is multiplication, no? Okay, 2 multiplications are there. 2 into 6, 12 will happen. Minus 1 plus 3 into 5, 15. So then this multiplication will happen. 12 minus 1 plus 15. Then addition, 1 plus
16 plus 15 minus 16. 15 then minus 1.
16 plus 12.
Then 12 minus
12 plus 15 then minus 1.
14 plus
Sir, addition comes first.
addition comes first. Sorry, yeah. No, first 3 into 5. See, first 2 into 6. Then 3 into 5. So 12. Then this one will become what? 15. This is correct.
minus 1
12 plus 15 minus 1.
minus 1 plus 15 will be 12.
Minus 1 with plus 15.
Well,
Minus 1. Afterwards, minus 1
Ah.
Plus 15.
Minus 1 and 15 will become what?
11 plus 15.
plus 14.
14 it will become.
11 plus 15.
12 plus
No, sir, 12 plus 14, sir.
12 plus 14.
12 plus 14 it will happen. Then it will become 26. That's the same result you are getting. But it will happen internally step by step.
Sir, in this expression,
Here you don't take because okay, in this okay.
converted to this one long, but you said float gets converted into long, but will the value be truncated?
It might be. Check it out actually. This question is when you are doing an operation between float and long, what will happen? Definitely float will get converted to long. But will the value be truncated is the question. Just check it out. Try to do long with float operation and just check it out. Small things, you will understand it, not a problem. But anyway, this is how the values are getting evaluated. Are you getting it now? First what happened? First division happened. Then this multiplication happens. Then means 2 into first division. Division is what? 4 by 2. Sorry. 6 by long, no? Yeah, 4 by 2 you did. So it is 2. After 2 what will happen? It will multiply. 2 into it is multiplying with what? 6. So here short got converted to long. In this expression short got converted to long, result is 6. Then multiplication happens. 2 into double, that is 12. So now long was getting converted to what? Double. So the result is 12. Then minus 1 plus 3 and all is there. Then 3 into 5 will happen. Now here int and float. Int will get float will get converted to int will get converted to float. Result is 15. Okay, so now this is the value now. 12 minus 1 plus 15 you have to do. So then addition has to happen. So now but 15 is of type what value now? Float. 1 is of type what value? Byte. Now byte will get converted to float. So it is 16. 14. Minus 1 plus 15 is 14 plus 14. Plus 14. Now 12 plus lastly plus 14, no? 12 plus 14. Lastly it will become, even though it is minus 1 plus 15 is happening. Minus 1 plus 15 is 14. Then lastly 12 plus 14 will happen, that is 26.
I understood that hierarchy of operations, whether it will become 27 minus 1 or 12 plus 14. 12 plus 20.
First minus 1 and 15 will get
No sir, first 12 plus 15 will
27 minus
Addition, no, sir.
first addition.
first addition 12 plus 15.
How will 12 is here and 15 is here now? How it will do addition? 12 and 15.
No, so first addition will be performed.
That's what addition. But addition has to happen between what? Minus 1 and 15. Addition has to happen between minus 1 and 15. Or 1 and 15, no? 1 and 15 it will take, not minus 1, sorry. What is the result? 28, I think. 26.
27 minus 1. 27 minus 1, 27 minus 1 and 26.
No, but the addition has to happen between this and this. That's what I'm saying.
12 and 15.
12 and 15.
No, it will not minus 1. It will take only 1 and 15.
Yes, sir. No, sir. 12 and 15.
If it has to take 1 and 15, then it will be 16.
16. 12 minus 2 will become minus 4.
Sir, that will sign conversion.
Huh?
It will happen
Sir, only if you put a bracket, then it will become 16. Otherwise, it will be 14 only.
No, sir. Because it's a subtraction.
Sir, addition is not, it is minus less. We are not multiplying, so it will remain positive only.
It will remain positive only.
Correct is sir. 12 plus 15 minus 1.
Huh? 12?
15, 27. 27 minus 1.
But my question is, why will 12 and 15 get added?
Subtraction.
But fine, but why is not 1 getting added with plus 15?
Because it's negative numbers, sir. Subtraction, sir.
Sir, if it
According to the rules, sir. According to the rules.
Okay, anyway, this is the process. Anyway, let's not worry about this now, because this will get into mathematics. Here we are just seeing what? The auto promotion rules. My interest here is not to teach you mathematics. Mathematics, you get into mathematics now. Okay, you do whatever you want. But here my intention was showing was auto promotion rules. Like how byte gets converted to short, short gets converted to float. I was mainly concentrating on that subject. So just go ahead and practice little, you will only get the idea. Okay, so if you want, you can see here we are not using braces. So that's why little confusion is there. Later on I start using braces. That time no doubts will be there. Understood? Perfectly will do it. Like what? First this, I'll put braces. Like here you'll be having now the code. In the source code what you'll do now? You'll put brace. First this should happen, then this should happen, then this should happen. That time you'll not have all this confusion. So preferably we have to go with what? Braces. Okay, that time you'll not have this confusion. But if you really want to understand like this only, you should be good in mathematics now, not Java. You should be good in mathematics. In Java we are learning only auto promotion rules now. Understood? So I am very weak in mathematics now. I am good in Java. I cover Java now. Okay. Better you say it like that. Yes or no? Okay. Anyway, this is clear now?
Yes.
I learned mathematics 20 years back now. I don't know mathematics now. Clear? So anyway, that is the auto promotion rules. So are you clear with all this now? So next, we have to move to the next data type, integer. Sorry, which one? Arrays. I'll move to the next data type. You have any questions till here? No questions? Zero questions now? Okay. Okay, I'll just finish off with one small example of an array. Just code this and come. Tomorrow we'll be going more detail into array. See now, why do you use an array? First of all, it's also one more data type used for what? Storing values. It's also one more data type used for storing values only. But why do you use an array? When you want multiple values, when you want to store multiple values of same type. Means, supposing you are getting multiple values from you get multiple values now and you want to store it in your application. Single value you can store it in what? Int. One value, two values and all you can store it in int I, int j. Means single value, two values I can store it in one variable. But if I start getting hundreds of value, I have to go for what? Arrays. Understood? So we have to learn now arrays now. Clear? So let's see how you work with arrays now. So what is an array? Array is a collection of similar elements. Array is a collection of similar elements and it can hold multiple values. Multiple values. One array can store what? Multiple values. That is the benefit of using it. Now second point, array is a collection of similar elements. First thing, array is a collection of similar elements and it can store multiple values. Next thing, array is a object in Java. Array is a object in Java. So what is object? It will start, don't worry, but array is an object in Java. Just I teach you how to work with an array. Work with that and come. Tomorrow we'll be seeing more into all these details. And array is an object in Java. Yeah, we'll see it with the code only. See, first I'll write the syntax. Syntax for writing an array is like this. Syntax would be data type. You have to use these braces. Okay. Variable name, sorry. Data type, variable name. Then use the square braces is equal to new. You have to use. Again, you have to say data type, and you have to say size. This is the syntax. Syntax. We'll learn it. Don't worry. So syntax would be data type, variable name, square brace is equal to new, data type, size. You have to use like this. Okay, now see this. How we'll do. See, if I tell you I want to store multiple values. Okay, first you have to see. Always remember. Till now you learned the primitive types. First, actually, what you do is see. This is the way you write the code. Int a is what? Int a is a declaring a variable. You are declaring a what variable? Primitive variable. Then next what you do? A is equal to 5. You are initializing the variable. There are two steps. Remember these two steps always. And this can be done in a single line. Int a is equal to 5. You can do both. Declaring and initializing, you can do it in a single line. It's optional. Same rules you apply for what now? Array also. See, this is one way how you can work with a primitive array, or you can do it like this. So first I'll show you in this way. Then I'll come back to single line. So let's see now. How do you declare an array in Java? Int a is how you declare. So now, okay, int z I'll take otherwise. So z is a variable of type what now? Z is an array of type int because I am using the trace. So this is called as declaring an array. This is actually called as declaring an array now. See, arrays are also very powerful. Declaring an array. This is declaring an array. Still array has not got created. And remember, when you declare an array in Java, there is no need of specifying the size. When you declare the array in Java, no need of specifying the size. So here you are only declaring it. Still it has not come into existence. So you have to bring it into existence. Z is equal to new. You have to use the new keyword. New int of 5. So this is nothing but creating an array. Creating and what? Initializing the variable. See, only array has been created. What has exactly happened here is, one array has been created, memory has been allocated. Okay, now the size is what? 5. 0, 1, 2, 3, 4. So what you learned in C, same thing, man. There's no change. Okay, there's no change. So the address of this will be stored somewhere in Z. Okay, so see, this memory got allocated and the address of this memory has been stored into Z now. That's it, nothing else. But see, Z has got initialized. Earlier Z was not initialized. Z was not having any array only. Z was only declared. Earlier only Z was there. It was something like this. But now Z is referring to an array. It's having the address of an array. Here, so now it is initialized. Z is initialized. But in the array, values are not there. Inside the array I am telling now. And the default values in the array will be what? 0, because your array is of type int. Now this is where default values you start understanding now. We are talking about default values now. So all the variables which you declare will have default values. Clear? So this is how an array is declared and all the values are 0. If you want, see this. One more thing. This is very important thing now. See, are you comparing this with this now? This is how you declare a primitive variable and this is how you initialize the primitive variable. This is how you declare an array variable. And this is how you initialize initializing the array variable. Creating and initializing is create the array and initialize the array variable. Only z is initialized, but the value in the array is not been initialized. Okay. So now see one more thing. As soon as you declare the array, you try to print something called as SOP z dot length. It will give you error. Anyway, it will give you error. Just print this SOP z dot length. Okay. See, means in Java what has happened is there is a variable called as length in all the arrays. In all arrays, whether you create an array of, see, we are learning right now an array of int. If you want, you can have an array of what? Float, double, everything you can have. First we'll learn int, then we'll go with float, double, anything. Okay. So right now we are creating an array, any array you create in Java. Okay. Any array you create. In that array there is a variable by name length. In that array there is a variable by name length. Right now here it has not got created. So that's why it will give error. Variable might not have been initialized. Understood? After creating, you print it. SOP z dot length. You'll find the answer. What is the answer you'll find? Fine. The length of the array is fine, no? So in C, your array is there, support is there, but it's very difficult to work with the array. To find the size of an array, you have to write logic. But here no headache only. If you want to find the size of your array, what will you do? Just call z dot length. Every array you'll have it as soon as you create it. Supposing I create an array of double, there also length will be there. Double D is equal to, I'll create an array. There also length will be there. D dot length will give you the length. Beneficial to the developer. See how easy the language is for you now to learn and code. Okay. And in arrays, you know now the index starts from 0 only. These are all rules same. Default value is 0 now. But what is the problem in C now? Just in these two lines in C, identify the problems. You can't find out the length. And all the values in your array will be what? Junk value. Here only, in two lines only you are facing so many problems. Okay, so that support, this data type is there in C language, but it is not having it's not a robust one, it's not a good one. So what we do is, now if you want, you can access the values there. Default, if you want, you print and see. How will you print the value? You can get the value now. Z of, I'll get the value now, 4. I'm saying Z, this is not 3, my Z looks like 3, man. Z of 4. So I'll get the value and store it in int p. SOPP, what it prints? 0 it prints. I'm getting the value from the 4th index, storing it in another variable called as p, and it prints me 0. This is how you can get. If you want, you can get another value. Z of 2. I store it in p. SOPP, what is the value? 0 itself, 0, 0. Okay, this is how you can work with an array now. So I declared an array, I created an array, I'm now trying to work with it. Okay, but the values are 0. Understood? It's as simple as this now. Okay, then next, if you want, you can visit the elements also. See here, this is, I am accessing one by one. But if you want, I can visit all the elements in the array. How many elements are there? 5 are there. Index starts from 0. Value is 0. I'll show, next we'll see how to initialize values here also. But let me access the value. See, this is how you access. For int I is equal to 0. I'm setting what? For loop. I less than what? Z dot length. This is where the length becomes very advantageous for you. What is the value of length? It was printing 5. Just print this first here. So I is 0, I less than, it is evaluated to what now? 5. Yes, I is less than 5, it will enter the loop. Understood? Then you can say I plus plus. So you can print SOP value of value in the, this is your print message, value in the, see this is print now, plus I plus index is plus a of z of I. So what will be the result? Int I is 0. Yes, I less than 5, it enters the loop. It prints whatever is there in double quotes as it is. Value in the, okay, 0 it prints. I is evaluated to what now? 0. 0th index is, z of I is what? Z of 0. Z of 0 is nothing but what? 0 itself. So it will print you like this. So the value stored in the array you can get one by one like this, okay, and or like this also you can get, or like this also you can get. Clear this? So now let us see, just focus on these lines, how you declared it, how you created it. Now how are you working with the array? Right now there is no value in the array. We store values and then we start working with the array. So let's see now how to store the values inside the array. Okay, how do you store the values inside the array? Very simple this. Now from here you continue here. So I store the values. Z of 0 is equal to 100. Z of 1 is equal to 101. Z of 2 is equal to 102. Z of 3 is equal to 103. Z of 4 is equal to 104. So here the values will change. Is you are overwriting, no? So in the 0th index it is this now. In the first index it will be 101. In the second index it will be 102. Like this. Now after you assign it, now write the same logic. Write the same logic. Z of 4, you are getting the value from what? 4th index. It will be 104. Get from the second index, it will be 102. And now you run this loop. It will print you 100, 101, 102, 103, 104. So now clearly understand this. This is declaring an array. This is creating an array variable. Okay. Now this is, these two steps you leave. This is step number 1. This is step number 2. First declare the array, then you create the array, then you initialize the array. This is initializing what? The array. Yes or no? Fourth step is what? These two are fourth steps. Using the array. Understood? Declare, create, initialize, then use. How do you use? Either you get single value or you visit all the values. Here why do I write using the value here itself means just I wanted to show you it's having default value of 0. But ideally what you do, you'll declare it, you'll create it, initialize it like this, and then you'll start using it, either getting one by one value or by using a loop, as simple as this. Understood? Now by chance, if you try to access a value, here you are accessing the value from the second index. Okay, I'll try to access the value from 6th index. Is there a 6th index now? Is there a 6th index? Or I'll try to store here Z of 5 is equal to 105. So I'm trying to work with outside the index. In C what will happen? It will allow you, it will compile. This also will compile. If you are trying to access a value now, see, try to use the array like this. I'm trying to get the values here. P is equal to Z of 6. I'm trying to get the value. See, happily it will compile. And when you see the result, it will be junk value. While retrieving this one, if I want, I can store Z of Y is equal to 105. Where in C? Happily it will compile. These two things are wrong now. This you are actually storing. This you are actually retrieving. You are trying to get the value from the 6th index. You are trying to retrieve. Yes or no? This is also error, that is also error. It goes undetected by C compiler and you get the error during runtime. Such a big headache. But here this error will be reported when? Compilation time. No junk values. So if you try to access a value outside the index, array index out of bound, exception will occur. Good only, no? When is the problem reported? Compilation time. You try to store also or you try to get also. The problem will be reported during compilation. These are the benefits of the language what you are getting. Data types are the pillar of any language. And you can see so many flaws are there in C's data type. Following, no? There are so many data types. Like what are the different problems? In one operating system they will behave in one way. And there is no rich support for storing big values. Understood? And so many problems are there. So in Java everything is neat, clean, organized. You compare. I am not saying Java is good. You open C also now and you start opening Java also now. Compare both the data types. Still I have not completed. 3-4 days. Then you see how rich this language is. At the same time it is what? Easy also. The same support. Imagine you are getting it in binary or machine level language. What will happen? Can you read? All languages are trying to give the same support. First of all, see, it is you need a easy language also. At the same time it should be powerful also. That is the requirement of developer today. He wants easy to learn language. At the same time it should be powerful also. Easy to learn plus powerful. And it is giving that to you. Yeah? So this is not allowed. Which one? Array index out of bound, it will give you error. So tomorrow I'll type and show you this. So today I've showed you single dimensional array. Tomorrow I'll go with two dimensional array also. You got multi-dimensional array support here. Single dimension also is there, same like C, but your data arrays are very powerful here. That's it. You can find the length very easily by printing what? Z dot length means the array dot length. Visiting the elements is easy. There you have to write complicated logic for visiting the elements. Working with an array is difficult there. Array is a good data type to store value, but how to work with that array data type is a big headache there. Junk values are stored and you can access any value from outside the index. These are all problems. Clear? So just do this. So what are the steps? Declaring an array, creating the array, initialize first, then use it either like this or like this. And during initializing, if you try to give a value outside the range, array index out of bound exception. And during retrieving the value also, if you try to get the value outside the range, array index out of bound exception. Easy, very easy. Only you have to type and practice this. 15 minutes you are learning array in Java. Yes or no? Just 15-20 minutes you spend time, you will finish up learning what? Array in Java. That simple it is. But in C, to learn an array you spend what? 15 days. That's the effort you have to put. Why junk value, why this, how this, how this. So difficult. Yeah? So I'll be seeing more on arrays tomorrow. Okay. It will be very interesting now. Yeah? Do you have any questions? Work on data types first. Primitive. Arrays will be discussing. Yeah? That's it.